Now we are discussing about Faraday's law of electromagnetic induction. Here you take one copper coil having one turn, I am assuming. It is connected to galvanometer or microammeter, like that things. Okay. Here I am keeping magnet north pole towards the coil. At that time, definitely from the north pole lines of force are coming, and these are having link up with the coil. When we are reaching towards the coil, that magnetic flux linking with the copper coil increasing. So here what happening? Magnetic flux changing. Magnetic flux, that is denoted with pi, it is changing. So delta by creating. So when magnetic flux changes, that maybe increases or decreases, in that case some current generated in the coil. So that is called Faraday's law of electromagnetic induction. If the magnetic flux change is zero, no induced current. So the generated current is called induced current. The generated current is called induced current. The generated EMF is called induced EMF. Induced EMF. EMF means we know that is electromotive force. So there must be some change in the magnetic flux. Then only in the coil, what generating? Induced EMF generating, corresponding induced current generating. So that is called what? Faraday's law of electromagnetic induction. Similarly, when we are taking north pole away from the coil also, current generating. In that case what happening? Magnetic flux decreasing. When we are moving towards the coil, flux increasing. When we are moving away from the coil, flux decreasing. Anyway, change in the flux creating induced current. So when we are moving towards the coil, if one direction deflection coming in the galvanometer, when we are moving away from the coil, opposite side deflection coming. So this is called Faraday's law of electromagnetic induction. So the generated induced EMF I am taking epsilon. So that epsilon is proportional to minus d pi by dt, rate of change of magnetic flux. For example, if it is one turn, some EMF generating. If number of turns if you increases, that EMF also increases. So epsilon is proportional to n, number of turns also. By combining these two, epsilon is proportional to minus n into d pi by dt. So this is called Faraday's law of electromagnetic induction. Minus represents what? Generated induced EMF. Due to that some current generating. That current is, when current generating, from this also what coming? For example, if this is coil, in this induced current generating. Due to this some magnetic field coming. That magnetic field opposing the induced current. When induced current flowing from the coil, it also generating some magnetic field, not our external magnetic field. From this also some magnetic field coming. That magnetic field opposing the generated induced current. Due to that we are writing minus. That is the importance of minus. So this is about Faraday's law of electromagnetic induction. Here what is the importance of minus? Induced current when generating in the coil, it also generating again magnetic field. That magnetic field is opposing the induced current. Due to that we are writing minus. These all things initially invented by scientist Michael Faraday. So these are called Faraday's law of electromagnetic induction. So to generate induced EMF, there must be change in the flux. That may be increasing or may be decreasing. Then only induced current generates.